Bias is something that is a part of our society, so there are detrimental effects when these biases are computed into algorithms. This has shown with current robotic technologies. The engineers of such technologies are focused on when and how bias influences the decision-making process. When an individual makes a biased decision, they prevent an objective consideration of the issue or situation. In result, ethical problems may arise. AI has failed to handle data based on gender, race, and sexual orientation. These effects can stem from interfering with employment decisions to influencing the quality of education or healthcare that an individual or groups receive. We seek to identify strategies that may prevent bias from negatively affecting those who interact with future robotic systems. We will do this by focusing on three significant robot use cases. Number one, the robot peacekeeper. Number two, the self-driving car. Number three, the medical robot. In 2016, it was reported that a police robot had a direct role in taking the life of a man in Dallas. A key facet of the case is the man happened to be African American. Given the current tensions around police brutality, governing bodies should require proof that the data for the algorithms used was derived from citizens of large urban cities. Transparency of data collection for AI should be made public to ensure community involvement so that fair outcomes are more probable. North Dakota passed a law in 2015 that allows the police to use armed drones. As a robot police officer is tasked with patrolling busy metropolitan streets, it will need to access data associated with the environment, including the sheer number of people. Researchers are devising litmus-type tests for discrimination by analyzing the data going into a program and the decisions coming out the other end. The results from these tests could be implemented into the AI software so that it has a moral model of sorts to go by when monitoring the area with bias. The design of driverless cars is a big problem in today's advances in AI. The US government recently released a checklist for self-driving cars which states that ethical judgments and decisions should be made consciously and intentionally. Algorithms for resolving these conflict situations must be transparent and disclosed to the US Department of Transportation through the National Highway Traffic Safety Administration. These disclosure efforts do not address the issue of bias. For example, how is the value of one's life going to be weighed over another? The history of the differential treatment racial or other groups have received, including by the criminal justice system, reveals the vast and persuasive impact of implicit bias. This history must be reviewed and datasets should be formed by multidisciplinary teams. These who are trained to recognize implicit bias should be an important part of the design process. It is well known that humans, including nurses and doctors, struggle with ethical decisions. For a medical robot, the ethical framework for making such decisions must be enabled, whether with learning algorithms or through direct programming. Like the robot car, the idea of teams being trained to recognize implicit bias should be a viable part of the design process. The value and wisdom of having diverse, in the various senses of the term, teams in the workplace is being increasingly recognized, including by the science and engineering. With that being said, there should be systems in place while monitoring robot behavior. For example, as a medical robot delivers the care needed, we should evaluate these movements using the patient race or gender as the independent variable to ensure all care is unbiased, even when that variable is changed in any way. In conclusion, relying only on the general population to identify bias, considering that implicit bias exists, is not how we address the question. These implicit biases will eventually lead to failure and possible harm to humans in various ways. We need a systematic and thorough ethical reflection by teams and trained professionals. Without them, the final decisions made by robots could exclude certain demographics based on factors such as age, race, gender, sexual orientation, or disability.